Okay, there we go. All right, and welcome back to another day of Proteus development. Again, this is just a landing page in case you want to see any more information about what Proteus language is. But yeah, we're just going to go ahead and get started and close this out where we left off at last time. Okay, so what were we doing? Alright, so we had started working on our parser. It was doing a little bit of stuff. Oh yes. No error checking whatsoever so far. Alright, I'm in Prot-C tests basic. Okay, so our scanner just goes through. Yeah, we've implemented our scanner, and well, our first step of our scanner, we're going to need to go back in and fill in the line and column information that we want. What I wanted to start to do next was take a look at maybe what our lexer is going to do. And so let's go ahead and just write the usage code for that. Alright, so we got a scanner, we have our lexer. Where did we left off? We had our scanner reference, initialize it. Alright, next in peak. Peak is implemented, next needs to go ahead and do something. So let's go ahead and just create one over here. Right, and the scanner is going to be our scanner. And so what we want to do is we want to go ahead and while lexer dot next does not equal no. I'll go ahead and print out that token information. And so yeah, let's just do this. Let token equal lexer dot peak. We're going to go ahead and force unwrap it again so we know it's an actual real value. And then we're going to print. Print out our token. Alright, so this is good. This should get us in a nice compilable state. And now our output should do nothing. One second, a spider. Gotta get rid of the spiders when we see them. Okay, so now we got an output of nothing. Excellent, that's what we want. All right, so let's go ahead and start looking at what we're going to do for our lexer. Now remember, the idea of our lexer is our file looks like this. Right, and so what we're going to do is start breaking these up into different tokens. And so this is where we're going to want to start filling in that line column information as well. But so let's go ahead and just implement the very first thing. Right, and so the first thing when we look at this is we want to check for certain characters. Certain characters are kind of going to be our signal that we need to go investigate a little bit further. And we're going to want this language to support Unicode identifiers and everything like that. But for now, we're just going to write the real simple version. But we'll stub it out so that it is going to be usable for us later. And so the real question is, we want to get that scanner, right? And so the character is going to be equal to our scanner.next, right? And so if at any point in time let's just do this. Guard, else return no. Right, so we may actually want to signal end of file token here. Yeah, that's what we're going to do. Alright, so we're going to get an end of file. So we're going to change this to be dot end of file. Okay. Alright. Okay. So if you're not familiar with the guard statement here, what this is going to do is it's going to basically, the else clause over here forces a return out of the scope that the guard statement is put in. So when we call next here, they're going to do guard let character. It's going to allow us to use character as the unwrapped optional version of itself without having to force unwrap it later. And if the scanner returns next, which currently the only time it ever returns nil, is when we're at the end of our stream. And so if that's the case, we're going to go ahead and return the end of file token. Alright, so now if our character, alright, so is identified. Alright, so like again, just looking at what we have here. Currently, so usually when you have identifiers, the first character in the identifier is actually a more limited set of characters than the secondary, or than the following characters inside there. So for example, you can't use, most languages don't allow you to have a 4 as the first character of an identifier, but you can use that numeric literal as the second character. So we're going to do something similar, and we're going to do that because without doing that, it makes it a little more ambiguous on when we go to parse numerical literals, especially if we want to potentially do something crazy like adding unit support later. So what this check is actually going to be is valid identifier signal character, and then we're going to pass in the character, and if that's the case, then we're going to go do some work. All right, and then for us right now, that's all we're going to do. We're just going to implement that, and we're going to see if we get that working. Really don't like the name of that function, but it's okay. We can rename it later. All right, it's going to take in a character. I'm just going to call it char. All right, so this actually needs to return bool. Oops. All right, and I don't like. Nope. Sometimes I like short names, but in this case, I don't know. Okay. So what we're going to do is we're going to just check to see if it is a ASCII character. I'm trying to remember what the NS string has a bunch of helpers here for us. Let's go look and see what those are. NS character set, that's what it is. Alphanumeric, capitalize, control, decimal, letter, character set. All right, so that'll be good enough for now. Okay, so we're gonna do ns character set dot letter character set. And these are class functions. How do I check within there? Testing membership. Character is member. Oh, yes, the unichar. I don't know if that's going to pass through. Let's find out. This might be as easy as this. Yeah, you'll see me move my mouse around still in Vim. I'm not quite as proficient as exiting modes and going back to the front of the lines as maybe I should be. But okay, let's see. I don't know if that unicar is going to work. Uint 16. I don't know if we can change that. Let's look at character. So this is one place where having code completion really helps, because you can just kind of dink around until you find something that looks like it's going to work. Counting characters. I really just want the API for the character class itself. I don't think, yeah, that's not right. Character struct. Here we go. Bummer. I don't know how to use this. Alright, let's see if the Googles know. NS character set is member Swift character. Let's see, character A, string, code units, unichar. That's right. I don't know if that's actually right, though. Is that going to work for compound characters? Okay. Okay. Well, let's give that a try. So the basic idea is that we're going to turn it into a string, and then we're going to get the UTF-16 view, and then I guess, my Unicode is very terrible, but according to this, it looks like it will take both the accents to get it. So I guess that's good. All right. Never be afraid to look something up. All right, so what we're going to do up here is actually do this. All right, where's my cursor? All right, so we're going to let set equal this whole thing down here. Oops. Okay. Character set that. Okay. And then we're going to do var is member equals false. All right, and so then down here, what we're actually going to do is return is member. All right, so then we're going to do for, let's do component. Well, it's really UTF-16 component in string character UTF-16. Then if the so that's not going to work, huh? Identifier set. Set's a reserved keyword. I don't think Swift is completely contextual aware on their keyword uses, but they might be. All right. So if identifier set dot is member, is that the right API? No, I've forgotten. Just character set, and the IOS one is fine. Is member, character is member. Member. Okay, UTF-16 component then is member equals false. All right, and if that's also the case, technically we could break at that point as well. Right, we don't need to go through, but I mean, it's gonna be what, one more iteration through the loop max, but that's fine. All right, let's see if this actually compiles. All right, so unidentified. Oh, okay. Whoops. All right. So that compiles. So that means it works, right? All right. So if we have a valid identifier signal character, then what we want to do is we want to read and build up a string based on all of those inputs that we have. So we say, yep, we have a valid identifier. We want to add that to our current content that we're parsing, and we're going to walk through each text until we hit basically a character that actually doesn't match that definition. So in the easiest sense, like right, if we're just going to do that right here, we're going to do content equals string of character okay, and then we're going to do while. Is a while? Let's see. I don't remember if this is valid syntax. Oh, it is. Okay. Good. So I can actually change this usage over there as well. All right. All right. So while let's see scanner next. What this is going to do is check for every character. And while that C is that. Oh yeah. Oh, can you do the where clause here? Where valid identifier. I don't know if that is doable. So there's a where clause in like the if-let statements. Let's try it. And so for now, all we're going to do is return you know, I should just make this a little more generic. Okay. Since basically I'm going to have to duplicate that code now. So if alright, I'm going to see here. It's just getting way too long to write. The set, well, let's try set. I think it works. We'll find out. Character is part of set, and the set is a character set, right? And we'll just go ahead and see if that code compiles. Oh, yeah, this one's not going to. Alright. Got these gnats flying around. It's annoying. For now, we're just going to do the character set again. Alright, we'll change that a little bit later. We're going to yank that out. We're going to paste it right there. Alright, we don't need that anymore. Character, identifier set. Okay. So, what's going wrong so far? Alright. So this guy. Alright. Oh yeah, and then I renamed this. Okay. Oh wow. Yank. Change in word. Paste. Nope. Alright. This character part of set. And I don't remember my backward keystroke. Okay, oops. Alright, this character part of set. Oh, I need to put the missing labels right. Right. Okay. This is another thing that is a bit annoying to me. I wish the labeled parameters were consistent throughout all of them. I would actually prefer each of them to be forced to be labeled, but that's okay. Okay. Content was never initialized. Where's that at? Right here. All right. Wow. Oh yeah. So here we go. Yes. So we're building it up. Good. That where clause is valid. So great. So this is what we're gonna do. We're gonna do content period append. Okay. Now our string is there. Then we're going to get out here, and we're going to have a valid character. Okay, and so we have a token. And so we're going to go ahead. I'm just going to assume right now it's an identifier. An identifier. It's going to have a string. It's going to have content. Perfect. Okay, so we're going to run this, and if this worked properly, we should get an identifier. That's a string of import, and then we're going to get null for the next one. Yeah. All right. So bin prot_c. Oh. Huh. I think the only place I'm doing that is here. So, I mean, let's just go ahead and change this. Let next, so token equal that. There we go. Perfect. Okay, so I mean, obviously this isn't working completely because we've only gotten 2 of these out, and as soon as we hit the one that's not a valid one, it's gonna bail out. So the thing I want to point here is there's an interesting piece about our scanner and the way in which we're using it inside of our Lexer. And so you notice that we actually got 2 tokens. And the problem is the space character between import and standard lib was eaten. It was not considered in the next token that we were going to go use. And that is a significant problem, right? Because if we're going to get in here and to print, what we're going to do is we're going to read that. We're going to say, oh, this is not a letter, so great. So print is your token. It's going to skip this paren, and then it's going to start reading here. That's not what we want at all. So what we want to do is basically this scanner.next needs to produce the right value, right? And that right value is the actual next token that we actually want to look at. So there's a couple ways we can do this. We can either, right here, what we can do is we can call scanner.previous to make it back up. But I don't think I want to do that. I think I actually want to do something else. I want to implement a function called stall. And so what stall is going to do is, so the reason I don't want to do previous is because I don't want to keep a back history through our text, right? So if we're coming through here and we go import, right, and we hit this, and I say, oh, I want to do previous, I'm going to back up a letter. Well, there's nothing stopping you from being able to call previous again. And then we should have R. And, you know, call previous again, you should have O. And I just don't want to keep all of that data in memory. So instead what I want to do is I want to keep, one, the API simple, so that when I'm using this, I can just call scanner.next and it's going to give me the right one. And we're going to use that through a little bit of context data. We're going to call stall. And so what stall is going to do is, in our scanner, we're going to do stall, right? And so all it's going to do is it's going to set a flag. Should stall equals true. Right, and so I'm doing this inside of a method because I don't want the API callers to be able to unstall, right? I don't want to be able to have them set this to false. They should always have to do that. So this is actually going to be private, but it's private to the file, so anybody in here can use it, so I guess there's not really a point. But that's okay. Var should stall is a boolean, and I'm just going to go ahead and default the value up here, right? Default should be false. Okay, and so what's going to happen here is first we're going to do a check here. Right? If should stall, all right, then we're going to go should stall equals false, and then we're going to return the current character, right? So what this is going to do is allow next to be called just as it's being called down here. And so when we run this again, we should actually not see both tokens. Perfect. All right. So this is now actually working correctly, at least for how we've implemented it. So now what we want to do is we want to introduce something to skip the white space. Okay. So what we're going to do is come up here, and in general, we're just going to go ahead and skip white space and move on. So while, let's just do let's see equals scanner.next, where is white space. Right? Just keep on going through. Okay, so let's create another little function up here. Character. And we're going to turn as character part of set. See set s character set. All right, so it's white space and new line. Let's just go figure out what it is. White space and new line character set. Okay. So in theory, this gets us back to, we've lost something now. Oh, right. Right. So yes. It's not quite right. We're calling next again, which is why the M is getting imported, right? So we're checking C. And so what we're actually going to want to do is if C, okay. If character, if this is white space, then skip it all. All right, so this is white space. Then we're going to go ahead and skip the rest of the white space, right? And then we're going to do stall again. All right, and so maybe I just want to call peak here. Peak, and then we don't call stall here. Oh, right. Just for now. Oops. Goodness, fat fingers. And I deleted my... Oh my goodness. Man, I really copied and pasted this thing all around. Okay. Okay, so we're getting closer. This is white space check is getting a little bit messed up. All right, so import works. Yeah, so basically what's happened is import has worked. We've gone through here and we have stalled, okay? And we've said, hey, it's a white space. Then we've called next again, right? And then next, yeah, this is looking pretty hacky, right? Okay. Yeah, I mean the character, I'm reusing that character and I should be using the peaked one. But this is ugly. Do I just want to do if let's seek? I could. Instead of calling peak again, to get this content, store the character, check it. Because I'm going to need to check it for a bunch of different cases as well. Or should I just, is there a better way to write this? Let's see here. So we're always getting next, right? So this is peak, okay? And then this is going to be stall. So stall and next should be the same thing in that case. All right, so I think what I don't actually like is storing this. I don't want to use this. So if scanner next append equals no, then we found one token. Okay? If that's not the case, right, then I'm just going to go ahead and, oops. I think I'm just going to stall it. Then we're going to do this. If let's see equals scanner dot next here all right, if that's true, right, let's equal that, and then we're going to go here. Oh. If it's white space, actually then I can delete this. All right. Okay. Let me go ahead and undo this. I'm not convinced. This is actually the better way to write this. All right. Yep. All right. So scanner next equals nil. Turn into file. Okay. Otherwise, if it's not nil, that means it's a valid character. Okay. So now we want to use that character. So then we're going to do while let next. Okay. We're going to grab that next character. Okay. If it's white space, great. Eat it. Right. If it's not white space, this is going to fail. Stall it so we can use that character again. Perfect. Okay. So now what we want to do is we want to go grab that character, right? And that character is going to be used for this guy. And I think what I'm going to want to do is just do this, right? And I think I'm going to want to update my helper methods to just take the optional and deal with it, so I don't have to deal with it here. Okay? And if that's the case, all right, so okay, we're gonna do that for now. Don't particularly like that. Okay, and then we're gonna do next. We're gonna append C. Okay, and so then we're gonna come up here, and we're gonna do that, and that. All right, oops. Make that optional. All right, now we made all that usage better, right? Oh, I forgot one of them. Oh, sorry, that actually. That should actually come up here. All right. Am I in a better spot? There we go. All right. So I guess I did a lot of that in my head when I was thinking about that. So I don't know if I like all the stalls, but in one sense I do. So the basic idea is now going through here. So get rid of the scanner. So the basic concept is to always use the actual scanner value instead. So actually, I guess I could use the scanner here. Yeah, so anyway, the basic concept is to stop the scanner from progressing when we've hit an invalid state for one of our conditions. So that way that character can be reused in the string again. And so in the case of the file, right, let's just cut out the file again. When we're walking through this import, what we're doing is we're walking through all of this. Okay, we hit that, we hit this string. Okay, we want to stall. We want to stall the scanner, so the next time we call next, we're going to be able to start using this token as the first character we're going to look at. And so when we hit white space, you know, we grab this and we say, hey, that's white space, awesome. Keep going until you find no more white space, which happens to be, in this case, the very next character. So in that case, don't eat that S, stall, so that the next time through, you can do it. So the reason I like the stall is that it's pretty consistent. Every time we hit an error at the ending case, we're going to call stall, and I think it'll end up being clean. But we'll see. It could be a really bad approach, but let's just go with it. Okay, so identifier. All right, let's go ahead and set it up how we're going to do keywords for right now. We're just going to have a table. All right, an array of keywords. So let keywords equal. All right, we have import, we have bar, and let. We're gonna have function. I'm sorry, that's Swift. Function that's good for now. Okay, so now, so we're going to do this if keywords contains content. If that's true, return out keyword content. Else, return identifier. I don't know why that thing keeps getting into my paste buffer. All right, great. So now we have a keyword. Now we have identifiers for print. Okay. So the next thing we're going to do is we're going to do parentheses. All right, that's a real simple one. Is parenthesis, right? If scanner.next Alright, so actually I'm seeing an issue here. Each one of these ifs is going to keep iterating on the negative case, and that's bad. Right, so we're just going to call it next. Right, scan let next equal scanner next. Right, so we're going to delete in word. Okay. Delete those. Okay. Oops. Don't know why the indentation's messed up there. All right, we're going to return what? Open paren. Yeah. And do we need to stall? We don't need to stall because we're not going to read any more characters. All right, else if next equals, right, turn dot close paren, else if next equals a quote. Then we're going to do something fancy-ish, right? We're just going to keep reading until we get an end quote. Oops. So it's actually not too unlike this guy. All right. So we're just going to copy paste that. Bar content, scanner peak. We could just grab next. Sure. Oops. Insert. Next. Okay. All right. So I'll scanner next where C equals C does not equal backslash quote. Keep adding it. Stall it. And then, yeah, at the end, we're going to return dot string literal, right? Okay. Comment. All right, so if I've done everything right so far, this should give us all of the tokens inside of our file. Right. So what I've done is I need to actually take this next one, right? So, So what I've done in this is I've basically, where's my file? There it is. I said, yes, it's a string, go through until you hit a quote and then stop. That's not actually what I want to do. I want to then also take the quote as part of my content, right? Scanner dot peak. A lot of unwrapped optionals here. And then I can stall. Content is that. No, and then I actually just want to go let it go through. Okay. There we go. Oh, what? That's amazing. All right, so we're missing two things. We're missing the end of file token, and somehow we've got another open paren. Open paren, close paren. Else if next equals. That's close paren, or open paren, that's close paren. What? Well, I think we're gonna maybe have to try to figure out how to attach the debugger to this. Right? I mean, just before we do that. All right, let's do that. Yep. Yep, that's awesome. Is this a bug in Swift? Right? If I delete this in Word, right, identifier, if I spell it right, oh my freaking goodness. Are you kidding me? I don't even. Oh my gosh. Yeah, that's just a bona fide bug in Swift. It's outputting incorrectly. It's probably the printer, right? Right, because we can do this, right? If switch on token, give it case dot open paren print case match on open, right? Okay, case dot close paren print case match on close default, don't do anything. Okay, and then come back over here and oops, I'll correct. Delete to the end of the line, append close paren. All right, let's see what the bug is. Match on close, match on open. token open paren. All right, that's fantastic. Okay, so what I'm going to do is I'm going to zip this up. That way I can, oops, create a bug report for this because that's just stupid. Print bug enum. All right. Okay. Whatever. Okay, so this is what I'm gonna do. Token open paren. Token close paren. Oops. Ah. Goodness gracious. Append. Print. Just rewrite it. So yeah, it's always fun when you're developing stuff, and the bugs are a mixture between your own code and the compiler. Well, in this case, it's not really, well, I'm actually not sure if it's the compiler or if it's the print function. But regardless, code that you don't own. Okay, so then the last thing we got to figure out is why we're not getting the end of file token. All right. And my guess is because we're going to do let next right here. Right, let next be this, and it's not a valid one. So this has a potential of being the end of file right here. If next equals nil, return end of file. Right. What is going on? Hopefully I have not messed this file up. Oh boy, okay. Insert if next equals nil, return end of file. Else oh, interesting. What is going on? Right? Here's white space. His white space includes new line characters. Okay. We go through here. We scan our stall. Next, it's going to get current. What is current? The previous character. Yes, so I have a bug up here. Right, so what we're doing is we're going through the next, and we said if the index is the end of index, then we're going to return nil. So what happens here is we return nil in this case. However, I then call stall, in which case, when I call next again, I don't actually get the nil back because I don't set the nil inside the current. Yes, so this is a state bug. Okay. So I need to actually do this. This is getting a little bit ugly. If the index content index, that's true, set current to nil and then return nil. Okay, so actually this is what I want to do. I don't want to return nil here. Right, this is, yes. What I want to do is do else here. And then, yes, I want to set the current to nil. If it's not the end of index, then I want to set the current to the context and then index, my indexer increases. Okay. Woo! Okay. We had a lot of open parens there. That's probably because I deleted a stall in my rampant typing of crap. Next equals nil, return end of file. Interesting. Because it's just a sea of open parens here. Oh no. Okay, so we're actually getting the end of file, but we're not stopping because we're never getting nil. Right, okay. Yeah. Ooh. I don't know if I can actually do this one. Yeah. Son of a gun. Okay. So delete 2. Oops. Delete. Delete 2. There we go. Alright, so I should actually never get nil. And in this case, the only thing that the only reason current would be nil is if we couldn't find an initial token. Okay, well, let's do the case for this. Print token and a file, and then also break. All right, let's break out of the loop. Oh, we ended up with 2. So we're breaking out of the switch. So I could label it and then break that. Or, I don't like that. So enums with associated data and like the equals operator, I have another blog post that I wrote about this and how we could make this flow much better. This might just be some bad code here. All right, so oops, insert token loop, break. So yeah. So in a language that says gotos are the stupidest thing ever, we can create named labels that break which is an acceptable use of go-tos? I don't know. But anyways, this should work now. Oh! Maybe if I know how to use them. Break, loop, what? See, that's what you get when you rant about something, and then it comes back and bites you. Token loop, break, token loop, break, token loop. All right. Am I just doing something really, really dumb? Like, I mean, we're getting the end of file. These do not need to be wrapped in brackets. All right. Let's go to developer.com Swift, and let's figure out why I can't break out of this loop. Okay, where is it at? Let's see. Where is that going to be? Advanced operators? No. Maybe it's just under control flow. Break. See, break and a switch. Control flow. Fall through. Yeah. Continue. Break. 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 Fall through. Labeled statements. Yes, right here. Break game loop. Am I hitting another bug? Continue game loop. Break game loop. Is this an... So maybe my rant was valid. Alright, let's get it so it's not a semicolon statement. I mean, there's a possibility that it's matching in here. Let's do this. Alright, see. Okay, that's rich. Oh crap, undo. What did I do? Oh my goodness. Fat fingers, build. There you go. Oh, see, that worked. Maybe I just didn't build. Maybe I didn't save and build. Let's hope that was it. I really need to go through my Vim and fix that issue where I hit build, I just need to save my buffers. Okay, whew, great. All right, so I can go back on my rant about GoTo here. But my inability to actually save a file before I compile is also questionable. Okay. There we go. So now we have successfully tokenized. See, I did it again. Ah, my fat fingers with that. Oops. Build. Okay. We saved. There we go. We have all the tokens. So I saw that question mark and I was like, no. Okay. So we have all our tokens. We've actually successfully been able to go about building, parsing this. The last piece of information I'm going to go add is the line numbers and the column offset. And that's going to be primarily used for error messages so that we can, so example, import, when we go write our AST, import is going to, when we create the AST, we're going to say the keyword import must be followed by an identifier and potentially a comma with other identifiers. And so what we want is the ability to look at those tokens. Like we're just going to suck all these tokens in, right? We're going to say import, and then we're going to grab this one, check, yes, it's an identifier, perfect. And then and move on. So I'm just sorry. When I was talking about that, I'm like, we're gonna need some sort of terminator, right? I forgot to. Actually, I need to know those terminators so that I know that this identifier was actually on a different line than this standard lib. So we're probably going to add in a new line identifier, or maybe like a terminal or something, so that we know the grouping in which things should be tokenized or should be interpreted together with. Yeah. Okay. Anyways, the line and column information is so we can get better error information. So the user we can say, hey, it's on line 7 and column 6. Okay, and so what we want to do is this. So we're going to do the nice cheap way, right? And so every time we call index successor, we are going to do, actually we're going to check one thing. Right? Current is a character, right? Yep, so if current equals, and like I said, we're going to do the simple case, then we're going to do line plus plus. Otherwise, we're going to do column plus plus. Right? And we actually need to set the column back to 0. Okay, that's great, but now we need to actually return that information. And so what are we going to do? I could either return a tuple here from next and peak as well and change this into a type that is going to return back a value, or I can make it a struct. So I like tuples. I've just found that there are lots of cases where I end up in running into bugs with the compiler when I try to use them. But since this is a type that's actually just going to persist, that's usually where I kind of draw a line between a tuple and an actual struct here. So what are we going to do this? We're going to call this I don't even know. Scan info, character info. Let's just call it character info. Whatever, scanner info. It's going to have a character. It's going to have a line, and it's going to have a column. Perfect. All right. And so the next, instead of returning that, it's going to return a scanner info. Okay. And then peak is going to return a scanner info. And I'm just going to have a little private helper function. That's going to take in C and info out, scanner info. So it's going to have a character, a line, yeah, and column. And so now instead of current, we're going to return scanner info of current. And up here, do the same thing. Yeah? I think that's good. All right. Lots of errors. Hopefully none in the scanner, though. Oh, right. Okay. Okay. Great. So now down here, this is scanner next and the file. That's great. So yes. So while let's see, we're going to delete that. We're going to call that info. Right. And then we're going to go delete, and we're going to go info dot character. No, that didn't. That. Oops. Oh, right. Info dot character. Boom. Yep. All right. So we got next. Great. Next doesn't equal no. Great. Is valid identifier. Next. Oops. Next. Character. Right. Scanner peak dot character. Scanner dot next. Okay, so this is going to be info dot character. Info dot character. Character, character, info, all right, so I got a bunch of errors. All right, it's not unwrapped. Did I mean to do? Yes, I did. What? It's not unwrapped. Did I not save it? Okay. Ah. Yep. If next equals There we go. Let's see if that broke anything. Excellent. Okay, so we have one append that's incorrect. Because it's taking an optional. And character. Kind info character. Valid identifier. Ah. Okay, string literal. Content equals string dot next. Oh my goodness. Okay. Okay. There we go. All right, so that's great. Now what I want to do is I want to go and add that data into the actual tokens itself. And so we're going to do int. I'm going to label them. All right. There we go. Paste. Let's go to the end. All right. Gosh darn, I keep losing my buffer. I haven't quite learned all of the keys that are all of the commands that end up clearing out my buffer. Okay. So I'm going to create the keyword. All right, we have content, but we need to get that. Okay. So, right. What we're going to want to do is we're actually want to capture the start. Right, so let's start equals scanner.peak. Delete that. Okay. Okay. Next is that. All right, then. Okay. Oh, I guess I can use next, right? Next is that one. Yeah, next is the start. Is that always the case? I think it is. All right. I don't even have to do scanner at peak. I can just do next. All right. Then I have to do that. Yeah, see, this is like where I need like if let, and then I can use it all throughout here, and like the refactoring of that sucks. But that's okay. Okay, we got next. We're gonna do the same thing down here. Append. Fine. Nope. Okay. What? Am I missing? Do I need to prefix these? Yes, I do. Of course I do. Okay. All right, let's see what happens. All right. So, keyword. All right, keyword 0, 1, boom, and we can calculate the length based on the context. Sorry, the content of the value. All right, column. These are line column. Okay, line 0. Yep, 8. So we're at 1, 2, 3, 4, 5, 6, 7, 8. That looks good. All right, 2, 1. First column. Boom. That looks kind of like an off by 1 error. Same with import. And open paren. No, this is my fault. So now that we actually have that data, I bet I don't need those. What do you know? Okay. String literal, second line in. Yep, line 1, line 2. Sorry, 0, 1, 2. Yeah, so this column I'm off by 1. And I'm off by 1 because whenever I call next, yeah, column actually needs to start at -1. Because each time through, I'm incrementing it. Yeah. Oops. Delete. All right, so okay, there we go. All right, there we go. We have now implemented, after much kind of fighting with Vim and Swift and a few bugs in the language that I'll get bugs logged for that. Now got a semi-working scanner to go through our text that can track. Actually, you know what? We're going to go ahead and go add those new lines, the new line tokens in there. those are actually going to be significant. So I was just about to end the stream, but new line, I don't know, terminals? Terminal? All right, we're going to call it terminal. Okay. So now we're going to come up here, white space, it's just white space. All right, so basically tabs and spaces. All right, if it's a white space, skip it. All right, so if next is that, so we're going to do this. If next, oh boy, next dot character equals a new line, return dot terminal, line next, what is it, next dot line, man, this is some bad code. That's okay. Sometimes it's better just get code down, get it kind of working in the shape that you think it's going to look, and then go through and clean this up. Like all of these implicitly unwrapped optionals, like that's not going to fly. Right here, I should just refactor that to be if let next right here, return in a file, otherwise, or even just guard it, and then, yeah, let's just go ahead and do that, right? So right here, right, guard, let next equal next, else, returned up in the file, right? If that's the case, that next is actually nil, just bomb. And so we can actually, instead of doing that, we can do this. Delete that. All right. So we don't need that one. All right. So there's that. Okay, now let's hear search. Next. Next. Yeah. See, I forget how to do the search again in Vim. See, that wasn't it. Yeah, so that does it on the line. Is it capital G? All right, let me check real quick. Vim global replace. How do I do it? What? Oh, that was, thanks Stack Overflow. Sorry if you don't want to learn Vim, then you can kind of tune out. But percent, yeah. Oops, what did I just do? I think this is right. If not, I'll have to read that page a little bit better. Yay! Okay, so let's just fix up the last remaining little errors here. Right, okay, so actually let's just do it again. Percent sort for next question mark with next. Boom. Yay, okay. So that cleaned up that code a little bit, right? So it's nice to be able to do this, but in some ways it kind of complicates code flow. But I have returns all over the place. There isn't really a good solution to that because we're using a switch statement and cases. I mean, the other option is, which we might do later, is break each of these down into their own functions. And we're definitely going to do that for the ASTs so that we don't have big, long code blocks with inside these if statements. But for the Lexer at the moment, this is probably fine. But anyways, I was saying it's kind of important just to get the shape of your code down. It doesn't have to be perfect. You can iterate it over time. to make it prettier and more robust. But when you just want to see if you can have things working, worrying about correctness, sometimes you need to just do that next. So, great. Perfect. I'm kind of weirded out that I'm getting 2 of these. All right, so I should get, oh yeah, okay, I should get this one. That's funny. Why is that happening? Dang it. Okay. If it's a new line, see, this is where we can go worry about correctness. We got the shape down, and now let's go fix up our code and get rid of the bugs and make our code actually correct here. So what the problem is the way in which I'm doing this. So I'm trying to count the columns, and so every time I call next, I want to increment the column, right? But it's what it right, and when you get to a new line, right, at the end of this new line here, yeah, it's really not, it's not reset yet, right? In fact, the line is even wrong, right? So you look at here, the line is wrong because it should be up here, right? And so this is why we have the column problem. All right, so let's go back here. All right. So instead of doing this, we're going to need to actually package up all of the data for the token, for the info, is actually defined right here. So what I'm thinking is, do I want to just call scanner info on this with null and then return scanner info here? Let's just do this. Right, scanner info is what? Right, it equals nil. So in this case, current equals nil, right, and scanner info equals, oh darn it, let's just change this to info. Change in word, info equals scanner info current. Yeah, and so this is actually, yeah. All right, screw that. It was a good try. Scanner info, current, line column. Oh, yeah, but I need to prefix this. Perfect. Okay, and then so we're just delete this. This is going to be garbage. That was really the source of the problem. Okay, index successor content is good. Okay, so regardless of what that is, we actually have our info now. I guess I could have technically done that. All right, so then Save. Then we can build. What? Oh. Scanner info. Right, delete to the end. Should I just make this be the current scanner info? Yes, it should. Right, so that's the current. So then we don't need that. Right, and so current character is nil, the line and column. Oh, so current is nil. Okay, so it should stall if current equals content index. No, it doesn't. It equals scanner info character. And then, yes. And this will reset it for the next time through. And then when we can turn current, oops, didn't save. Then if current equals a negative, yes. Character, if that equals a new line, where's scanner info now? Oh, deleted word. Okay. Yeah. All right. That's looking better. And that cleaned that up a little bit better too. Yeah, that previous method that I had, like that was a really bad use of state. I was trying to save a few keystrokes, which ironically didn't save any because I actually only needed to create the instance of the current one time, and before I was creating it like 3 different times, and I was storing bogus data. So yeah, that was just a bad choice. This is much cleaner. That actually will do what we want it to do, and we can see that we actually have all our tokens out coming out. All right, so let me make sure everything's saved. We're going to shut this down for today. Yes. So again, all right, that was, oops. I have this USB drive and like it shuts off. And then OS 10 decides to lock everything while it spins back up. That's awesome. All right, so we're going to do one more time to make sure that this actually is all good. We got import at 00, that's great. We got standard lib at 07, that's good. We fixed our off by 1 errors. Our terminals are ending in the right spots. Okay, and this will allow us to actually make better decisions about whether or not these terminals are actually necessary, if they change the context or if they don't. In some cases they won't change the context, like scopes, for example. If we have scope, if we have curly braces that introduce new scopes, those terminals are likely not going to matter. But like for an import statement here, we can see that, hey, yes, indeed, we need to know that this identifier followed by this identifier was indeed separated by some sort of terminal. And so the terminals essentially act as the semicolons in the language, and so we're implicitly adding them, you could say. We'll see if I need to make that algorithm a little bit smarter or not, but for now that'll work great. Terminal line, print. Okay. All right, so I'm going to go ahead and call it quits for this live stream. We got some good work done, and next time we will tackle probably going to build the AST from this, and then generating some C code. So we'll see how that goes. All right, bye.